Welcome everyone. Today we are looking at solar energy. Before we dive in, can you tell us, what actually is solar energy?
Of course. Solar energy is the energy that comes from radiation emitted by the sun. When sunlight hits a solar panel or collector, that energy can be captured and used. It is completely free, produces no pollution, and is available every single day. It is one of the most abundant and promising sources of renewable energy we have.
So the sun gives us light and heat, but how exactly do we turn that into useful electricity or warmth for our homes?
Great question. Solar energy can be converted in two main ways. First, it can be converted into electricity using photovoltaic technology, that is the solar panels you see on rooftops. Second, it can be used directly as heat, using solar thermal collectors that warm water or air for homes and buildings. Different technologies are used for each purpose, and we will explore all of them in this lesson.
I have heard the term photovoltaics before. What does that actually mean, and how does it convert sunlight to electricity?
Photovoltaics, or PV for short, is a technology that converts sunlight directly into electrical energy. The word itself comes from the Greek word for light, and the name of the Italian physicist Alessandro Volta. In simple terms, when photons of light strike the surface of a solar cell, they knock electrons loose, and that movement of electrons creates an electric current. It is a direct, silent, and completely emissions-free conversion of sunlight into electricity.
Can you walk us through exactly how a photovoltaic cell works, step by step?
Absolutely. The process happens in 5 steps. Step 1. Sunlight hits the solar panel. Light is made of particles called photons, each carrying energy. Step 2. Those photons are absorbed by the solar cell, usually made of silicon, and their energy excites electrons, knocking them free. Step 3. Those free electrons flow in one direction, creating direct current electricity, or DC. Step 4. That DC electricity flows through the circuit when connected to a load or the grid. Step 5. An inverter converts the DC electricity into alternating current, or AC, the type used by all household appliances.
What are the main physical components you need to build a working solar power system at home?
A home solar power system has 4 key components. First, the solar panels themselves. These capture sunlight and generate direct current electricity. Second, an inverter. This converts the DC electricity from the panels into AC electricity that your appliances can use. Third, a battery. This stores surplus electricity generated during the day so you can use it at night or on cloudy days. And fourth, the mounting hardware and wiring, the structural frame that holds the panels in position and the cables that connect everything together safely.
You mentioned 3 types of solar technology earlier. Can you explain what each one is?
Yes, there are 3 main types. First is photovoltaics, where solar panels convert sunlight directly into electricity. This is the most common technology you see on homes and solar farms. Second is solar thermal, where solar collectors absorb heat from the sun to warm water for use in heating systems, very efficient for domestic hot water. Third is concentrated solar power, or CSP, where large mirrors or lenses focus sunlight onto a receiver to generate intense heat, which then produces steam to drive a turbine and generate electricity, mainly used in large-scale power plants.
Let us look at solar thermal in more detail. How does a rooftop solar water heater actually work?
A rooftop solar water heater is beautifully simple. Flat panel collectors are mounted on the roof. These dark-colored panels absorb heat from sunlight very efficiently. A heat transfer fluid, usually water or a special antifreeze solution, circulates through pipes inside the collector, picking up that heat. The warm fluid then flows into a well-insulated storage tank, where it heats your domestic hot water supply. On a good sunny day in the UK, a system like this can provide most of a household's hot water for free.
What are the individual parts that make up a rooftop solar water heating system?
There are 4 main components. First, the solar collector on the roof. This is the flat panel that absorbs heat from sunlight. Second, a circulating pump. This moves the heat transfer fluid around the system. Third, a heat exchanger. This transfers the heat from the collector fluid into your domestic water supply without mixing the 2 fluids together. And fourth, the storage tank, a well-insulated cylinder that holds the heated water ready for use. Together, these 4 components form a complete and highly efficient solar heating circuit.
Now what about concentrated solar power? How is that different from ordinary solar panels?
Concentrated solar power, or CSP, is quite different from photovoltaics. Instead of converting sunlight directly into electricity, CSP first converts sunlight into intense heat. It does this using thousands of large mirrors called heliostats, which all track the sun and reflect its rays onto a single receiver at the top of a tall tower. The concentrated sunlight at that receiver can reach temperatures of over 500 degrees Celsius. That extreme heat is used to produce high-pressure steam, which spins a turbine connected to a generator, exactly like a conventional power station, but using the sun as the fuel.
How does the complete CSP system work from the heliostats all the way to the electricity grid?
The heliostats in the collector field continuously rotate to track the sun and focus reflected light onto the receiver tower. The receiver heats a fluid, which flows down to a thermal storage system, typically tanks of molten salt, that can store the heat for hours. When electricity is needed, hot fluid from storage passes through a heat exchanger, producing steam. That steam drives a power turbine, which spins a generator, sending electricity out to the grid. The control room monitors and manages the entire process.
You mentioned molten salt storage. How does that allow a CSP plant to generate electricity even at night?
This is one of the most exciting features of CSP technology. During the day, when the sun is shining and the mirrors are working, surplus heat is stored by pumping hot fluid into tanks of molten salt, a mixture of sodium and potassium nitrate that can hold heat at very high temperatures for many hours. After sunset, when there is no sunlight, that stored heat is released from the hot salt tank, used to produce steam, and drive the turbine as normal. This gives CSP a huge advantage over solar panels. It can generate electricity around the clock, not just when the sun is shining.
Can you explain what parabolic trough CSP plants are and how they differ from power tower systems?
Parabolic trough plants are the most widely deployed type of CSP in the world. Instead of a central tower with thousands of heliostats, they use long rows of curved mirrors shaped like a parabola, hence the name. These curved mirrors focus sunlight onto a receiver tube that runs along the focal line of each trough. Inside that tube is a heat transfer fluid, often a synthetic oil, which is heated to around 400 degrees Celsius. That hot fluid then flows to a central power block where it produces steam to drive a turbine. The key advantage over tower systems is that the technology is more mature and has been operating reliably since the 1980s.
What are the main parts of a CSP system and how do they all connect together to generate electricity?
The CSP generation chain has 5 key stages. Stage 1, heliostats, the large mirrors that focus sunlight onto the receiver. Stage 2, the receiver, positioned at the top of the tower, it absorbs the concentrated heat. Stage 3, a heat transfer fluid, this circulates through the receiver, carrying the thermal energy away. Stage 4, a steam turbine, the hot fluid heats water to produce high-pressure steam, which spins the turbine at high speed. And Stage 5, the generator, connected to the turbine shaft, it converts the rotational energy into electricity that is fed to the grid.
How exactly does CSP go through all those stages to generate electricity? Can you take us through the process step by step?
The 3 key steps are these. Step 1, concentrated sunlight creates intense heat. The mirrors focus sunlight onto a central receiver, heating a fluid to temperatures between 400 and 1000 degrees Celsius, far hotter than a conventional boiler. Step 2, the heated fluid boils water into high-pressure steam. That steam is then piped to the power block. Step 3, the steam spins a turbine, which drives a generator to produce electricity. What makes CSP particularly interesting is that the process from Step 2 onwards is virtually identical to a traditional coal or gas power station. The only difference is that concentrated sunlight replaces the fossil fuel burner.
That is fascinating. But can CSP do more than just generate electricity? Are there other uses for those very high temperatures?
Absolutely. This is one of the most promising aspects of CSP. Because it produces very high temperature heat directly, it can supply industrial processes that need large amounts of heat but do not need to convert it to electricity first. For example, it can provide the extreme heat needed in steel and cement production. It can supply heat for chemical manufacturing processes. It is used in oil refining to heat crude oil for separation. And it can be used in food processing for drying and pasteurization. In all of these cases, CSP replaces fossil fuel burners, cutting carbon emissions from some of the world's most energy-intensive industries.
Finally, you mentioned CSP can be used in water treatment. How does that work, and why is it important?
This is a particularly important application in hot, arid regions of the world where clean water is scarce. CSP can provide the high-temperature heat needed to drive water treatment processes. In seawater desalination, CSP heats seawater which then evaporates and condenses as fresh, drinkable water, removing all the salt. In distillation systems, CSP-powered heat is used to purify various types of contaminated water through distillation columns. And in water purification, the heat is used to disinfect water and kill pathogens. In regions like the Middle East and North Africa, combining CSP with desalination could provide both electricity and clean drinking water from nothing more than sunlight. Thank you for joining us for this lesson on solar energy.
This lesson is brought to you by tutorwarren.com, an innovative learning resources platform.